Hi, welcome to DevOps Hands-On Training Online by Belinda Walia. In this video, for the next 15 minutes, we will go through how GitLab Runner workloads can be optimized to run an autoscale in a Kubernetes cluster using Kubernetes technology and the built-in GitLab Runner concurrency and demystifying the power of these technologies out of the box. So without further ado, let's get started. I have a README and I have the GitHub repository for this project, which you can refer to it later. And we will already assume that you're running a decent Kubernetes cluster. So I am running a decent cluster here, and about 6 worker nodes, 2 control planes, and it is already running quite a lot of databases: Postgres, MySQL, GitLab itself, Longhorn storage system, which is highly available distributed block storage system for Kubernetes, and it is already using quite a lot of resources, about 60 gig of memory, because I'm running Elasticsearch as well, some vector databases, and we're not running many GitLab runners at the moment, because I will add one by one and show you how to add register the GitLab runners to the GitLab server and autoscale as we require more and more CI/CD pipelines to run and efficiently and consume the unused storage, the memory, the CPU in an existing cluster. I think this is really cost effective because in a daily basis, infrastructure cost and optimization is a big issue in enterprises, and if you can already tap on the unused resources of a Kubernetes cluster to run your CI/CD pipelines, that would be very efficient, and that's good for the environment as well. So okay, so let's first look at what we have. As I said, we have a Kubernetes cluster, we have Longhorn storage system, GitLab is running already, Postgres is running in this cluster, and GitLab is using Postgres and MinIO. They're all running in here, and basically yeah, so there's MinIO running as well, and we also have a GitLab. Go to gitlab.workstation.co.uk. We have the GitLab server running as well within the same Kubernetes cluster. You can obviously, depending on your choice, you can run it separately in a different environment. For production, you can have a different cluster running. But anyway, so let's first go through the projects which I have already set up. I have a dummy set of CI/CD projects in GitLab. I've already prepared the CI GitLab files, YAML files, so that we can test it. And one thing I haven't got is the runners yet registered, because I want to show you. So let's go through the runners we have. Let's go through the bash script as well, what we have. So this is the bash script which is shipped with this project in the GitHub for reference. So it actually is really simple. Using Helm, we install the GitLab operator first, and then when the deployment is ready of the GitLab server, we then install and register the runners for various workloads, and that's the process which I'm going to go through. And there is already a video deploy GitLab in Kubernetes via operator on my channel, so feel free to go and watch that first. It will help you. And let's start with the token. So we will need to we will need to grab some tokens from the GitLab UI, which in a real environment you would have probably Vault, HashiCorp Vault, or Azure Vault, or other secret management system from Amazon or GCP, and you would actually pull those master tokens from that vault, and then using an API you would create these runners and register all automatically. But I'm going through this process manually just because we want to go through this process and understand the concepts as well. So in the one of the Python app CI/CD repository, code repository, go to settings and CI/CD, and then click on the runners. And obviously we have a couple of runners already running, but let's delete them actually, and the other one as well. I have two repositories to show different kind of runners running at the same time in parallel. Okay, so that is the runner 3 Alpine. Okay, let's delete that as well. So now we will create a, let's refresh to make sure it's deleted. Yeah, so we don't have any runners, and let's start with the ones for the Alpine. And we do want to tag these runners because you can then run different type of workloads for different type of applications. Maybe you want to run some applications and build in an Alpine container, Docker image. So it's always a good idea to tag them. So we will call it runner. Let's call it runner 1 Alpine Linux, and then we will create that. Okay, and this is the important step. This gives you a GLRT token, which is GitLab runner token, and copy that. And then you would need to, for the Alpine one, which is the Alpine image is here. Let's see. Yes, this first one is the Alpine 3.19. So here is what we need to put the registration token in the bash file. And the same we can do for the other Python application. Create runner, and in this we will call it Ubuntu Linux tags because we want to run some let's call it runner 2 Ubuntu Linux. We want to run some applications which require Ubuntu Linux specifically. So let's do that as well. So we will get the token for registering this runner as well. So I have created a Ubuntu manifest as well, as you can see. So now this bash script is ready actually to register these. So it's going to reinstall the operator and everything, but doesn't matter because we already have it running. So excuse me. So we should have at the end of this process, if we go to view the runners, we should have the runners created and up and running. So Alpine 1, Ubuntu 2 is coming up. Yeah, it's not live yet, and it should be running. Actually, we can check using kubectl. Yeah, we can watch it. And as you can see, these runners now are starting up. They're not ready yet. They're initializing. And you should be able to also see in the, yeah, there you go, in the dashboard as well. It's a bit easier to visualize. And if you look at the logs, as you can see, this runner is up and running. And this is the Alpine one. And if we go and look at the Ubuntu one, that should also be up and running. Let's look at the logs. Yeah, the executor is initializing. So any minute we should see them. Actually, runner Alpine is already showing 1 out of 1, so it's up and running. So that means the CI/CD pipelines should be able to pick those up now and run your workloads. And so actually we can see there's already one pipeline. Actually, it seems like there's a job which was running yet 3 hours ago, but let's see if there is any other jobs for the other ones. There's two projects, obviously. I'm going to, okay, that's 1 hour. It failed because I didn't have the runner running. But anyway, we'll fix that in a minute. So let's go to the Python app when both of the runners are up and running. Yep, they are. And first, let's go to in the Python app and let's have a look what we have first. So in the Python app, we have a test bash script to test benchmark these. But before I run that, actually, what I will do is I will show you the GitLab CI YAML file, .gitlab, sorry. This just simply runs a Python image, which is pulled up from Docker Hub, and then it will just do a Python version check, displays on the screen, and then it will actually install Pylint and a Flask, and then it will just run a Flask application simply, and I mean test it. And then in another file we have we can run it as a tester. But anyway, the point is you can create a pipeline workflow to compile applications, build application, Python applications, or any other applications which require testing, unit testing first, and then if the success criteria, the quality criteria is passed, your pipeline can then display certain messages, send a message on Slack or email that it can be promoted to the next stage, maybe from a test environment to acceptance or whatever. This is using two tags, Ubuntu and Linux. That means this pipeline, when we push this code, will only run the workload in a runner where we have the matching tags Ubuntu and Linux. Remember, one of the runners we created had that. So okay, let's make a quick change. Just first, let's just test it, and because if I make a change and push, it will automatically trigger anyway this test, but we can also run it manually. So let's go and do that. Curl, and this is the project 1. Yep. So let's run project 1. Okay, it has successfully triggered that pipeline. Let's see which one of them is DevOps. Yeah, this is the one. As you can see that this is oh, okay, we have some kind of error. Let's see what's going on. Okay, 11 seconds it started and then it failed. I think the GitLab Runner not found, service account not found. Okay, so we have to go and fix that. Let's see, the service account is not found. This is the bash file I ran. Why is the service account not found? Because we have okay, we have the service account. Let's check the service account. We did say in the Helm when we installed using this, we did say create the service account. So let's see which service account, GitHub Runner. So it's not found, and service account is GitHub Runner. It should have created automatically. Okay, so where do we do Helm upgrade? Service account create. Okay, I'm just gonna rerun this again. I think, yeah, this should create the service account. There's no reason why not to create the service account. Okay, that has failed, but we can run it again. And actually we can see in the dashboard workloads as we have, okay, it's I'm not showing at the moment, but it should come up in a minute. Okay, so okay, this is failing. The service account again is not found. It's not creating the service account. Maybe let's check we are on the correct cluster. It is the correct cluster. And let's run this. Actually, let's run this manually. There's the service account under runners Kubernetes, and here's the service account missing. So we will create service account. Actually, let's do one thing. Let's create service account Ubuntu, and let's create the service account Alpine, just so that if at least one of them works, we should not have to completely lose track of it. So service account now will be created, whatever's in the file. So I'm just going to run the Helm upgrade command. So that's the Alpine one, and I will run the Ubuntu one as well. That should also create the service accounts. But what we can do is we can actually watch the let's see if we can see the, okay, so I'm in the correct cluster now. Okay, so let's wait for these to be up and running again, because I had obviously created these again. So it's going to create the Alpine runner and Ubuntu runner again with the latest actually let's do one thing. Helm install. I will uninstall and reinstall both of them again, just to be absolutely sure that we have nothing running before GitLab Runner. Okay, so that should be uninstalled, and then Alpine one as well, and Alpine, and I'm gonna go and rerun the Alpine, and when these are now deleted, the pods are deleted, old ones, so let's just start again. And now the next one is Ubuntu. And what we want to do is watch the runners being created. Yeah, okay. And another thing I wanted to mention is there's a congruent parameter you can pass using Helm upgrade or install to tell GitLab how many congruent runners it should run in case of there's too many requests to create the CI/CD workloads. So this is 2, but we will play with it and we'll try increasing it once we have that. So let's wait for these to be up and running, and obviously we can see these in okay, let's see, workloads are in all namespaces. Okay, this is not working. Okay, but what we can do is let's start here. Okay, I want a different kube config. Okay, let's use so K9S is a bit better. If the online dashboard is not working, it's not a big deal because we can actually see the logs. Okay, so that's fine. So Alpine and both of them are up and running. So now these jobs which were failing, hopefully when we push this and trigger this again, it should not fail. So let's do the curl command again. Here's the trigger number 1, project number 1. Yeah. So we should see that job spinning, and which one was that? Just now. Okay, it's still failing. Let's see why. Invalid cluster IP holder, invalid cluster IP placeholder. Okay, let's see if we are using Okay, so I have probably missed the initializing the yeah, okay, so but I know the IP for that anyway from my load balancer. Yeah, actually, thank you for that suggestion. Let's see if that works. Yeah, that is correct. So we will rerun it, and the IP is that. So what we can do is just fix that here, and there is no defined, not defined here anyway. So just in the Alpine one. Okay, so we can reinstall Alpine one. Okay. And in the meantime, what we can do is we can run the other workload because we have two jobs. And the second one, hopefully that will run fine. Let's see. Okay, token. Oh, I need the token, sorry. Yes, I need the token which is correct. I mean the correct token. So yeah, sorry about that. That's the one. Okay, now that should trigger the second project we have, and that is this one, Python app. So let's see if that's working. Okay, at least Python app CI/CD pipeline is triggered and is running, as you can see. Is that without any errors? So we will, in the meantime, watch this and fix the other one in the meantime. So actually, before I will do uninstall Alpine container runner altogether, and then I'll just reinstall. Yeah, let's do that, and then we can watch the. Actually, let's use another. Yeah, we can watch this now. So as you see, the new container is up and running. Now, the interesting thing which I want to demonstrate as well is that we only have two concurrent. So if I send another request for running the, let's say the same job we had before, project number 2. If I run it again and again, just let's say 3 requests, right? So now we have this situation where there's a lot of jobs, and you see 2 are running, but if you have a very busy GitLab environment and too many developers, teams, asking for CI/CD workloads, resources all the time, so you can increase depending, obviously, the capacity of your server. I mean, I have a massive Kubernetes cluster, so it depends on the capacity of your cluster, Kubernetes cluster, and make sure you limit the memory usage on these runners. But in a nutshell, you should be able to deal with that by just simply saying, I want to run 10. Actually, let's try that in the Alpine. So I will rerun Alpine, and then what it should do is, instead of just having 2 Alpine at a time, now it will, let's wait for the new runner to be up and running, because this will have that you can run concurrently 10 runners. So if we have 10 requests, it should not be a problem for these. As you see, these are getting finished. They're finished. Now let me send, actually, let's just send it. What's the 10? Actually, no, just send it each second. Let's just send a few. Yeah, 2, 3, 4, 5, 6, 7, 8, 9, and about 10. So we send about 10 job requests for this app, RCSE. So what you should see is that they're all pending, right? But the Kubernetes cluster is able to run many runners at the same time. it should be able to do more than 2 soon, because at the moment it's running, you see, it's running definitely running more than 2 at a time, because we have so many requests for the GitLab runners to be dealt with at the same time. So that's a very powerful feature. You can literally auto-scale and hyper-scale these runners by playing it just by the configurations. So for the Ubuntu one as well, let's do the same thing. I'm gonna try with let's say 20 concurrent ones, and I'm gonna first do uninstall the runners for Ubuntu and reinstall. Helm upgrade and yeah, that one. Okay, so now we should have also Ubuntu runner running, and if we send for the other project CI/CD pipeline, other project, as you see, most of them are running, but some of them are failing, but we can find out the reason why, and that's probably because of a different reason anyway. Yeah, some issue with the name. It's not always reliable, but yeah, you got to find out which jobs are failing and troubleshoot a bit. There is a built-in Grafana Prometheus monitoring as well, by the way, but you can hook it up with more sophisticated monitoring, probably Elasticsearch, Dynatrace, or Splunk, or Grafana Prometheus separate instance for troubleshooting these. Anyway, so there is another job, which is the this one in here. Yeah, so we haven't triggered that pipeline actually, so let's wait for this Ubuntu to be up and running. Yeah, it's running now, so 1 out of 1. So what I will do is now I will trigger the other job, which was 1 before, and I will do the same. Watch and just run it like, I don't know, yeah, watch it so it just repeats itself. And now the same thing, you should notice that these are running more, running at the same time more than, and the rest of them are put in a pending state because we have increased the limit. So let me stop that, and then you see how many runners are running simultaneously, and they are running on a different node, worker node. Well, there's one beefy worker node I have with 128 gig of RAM, and yeah, so it's probably going to pick up that first. But as you start to run these more and more, as this node is getting utilized more and more, we can then see it automatically moving the other runners to different workers. So let's see our pipeline. That should be, so many of them should be running now, as you see, how many at the same time, otherwise they will go in pending. So so that is really cool feature of GitLab and the runners by the nature of it, by the nature of Kubernetes. And this is why we should run GitLab in Kubernetes fully, because it's using all the unused storage, unused resources, storage, CPU, and the rest of that. And if we try to go back to our K3S dash again, if I can log out and log back in, yeah, let's go back in there again, and in the GitLab runner, you should see that it's like running 9 but pending 4, and it's auto scaling automatically based on the nodes we have, how much memory is utilized by this GitLab runners. But there's probably some kind of limit, but you can increase or decrease the limits based on your capacity of the cluster, and a certain type of nodes you can say only run Alpine Linux because they don't have a lot of memory or CPU, whatever. But yeah, the total usage is wow, 144 gig memory is used. But anyway, that should be recycled because not all of that is used. But these runners are not doing awful lot at the moment. They're just simply building some, compiling some software, but you could do more sophisticated stuff using these runners. As you see, there's a lot more running at the same time, and they all are in parallel processing, doing whatever it needs to be doing. This is building a Docker image, I think, or something like that. No, that's actually installing some applications, Helm and kubectl, and then it's just, oh yeah, it's just displaying the Kubernetes cluster state in a job. That's just a test, but you would be probably doing a lot more sophisticated building, the software testing, pilot, and as we had in one of the jobs. Yeah, so I think that pretty much is all I wanted to cover today. GitLab Runners at HyperScale using Kubernetes, auto-scaling, and you can actually build a very sophisticated runners environment using EKS, AKS, GKE, where you can have the node pools auto-scaling when there is a lot of demand for these pipelines, and you can spin up some nodes and VMs, and of course using automated schedulers available on these platforms. And when these number of pods decrease back to not much, if it's all the pipelines are run and finished, then they would they would auto downscale itself. So there's a very, very cost efficient system you can build and scale, and a benefit for the development teams to run various pipelines, and QA teams, and the business overall, save business a lot of costs. So thank you for watching this video, and I think we covered within 15-20 minutes quite a lot, and I hope this video will help you use GitLab better, have a sophisticated GitLab Runner environment, and increase the productivity of the of your business. Thank you very much. Cheerios.